Good afternoon, everyone. Welcome to the class on operation research. And in today's class, we'll discuss unbalanced transportation problem. So here, when we talk about unbalanced transportation problem, the possibility of this unbalanced transportation problem you will get when the total sum of supply is not equal to the total sum of demand. Here, if you see the total sum of supply, that is 70 plus 55 plus 70, that is 5, 14 plus 5, 19, 195. Total sum of supply is 195. If you see the total sum of demand, 85 plus 35, 120. 120 plus 50, 120 plus 50, 170. 170 plus 170 plus 45. So that is 215. So if you see the total sum of demand, that is 215. Total sum of supply is 195. So you can see clearly from this problem, guys, that the total sum of supply is not equal to the total sum of demand. In case if the total sum of supply is not equal to total sum of demand, you cannot solve this problem like by applying any method, either northwest corner method or least cost method or Vogel approximation method. We cannot do. We need to make sure that whenever we are solving a transportation problem, the metric should be a cost matrix, and where objective should be minimization, and the total sum of demand should be equal to total sum of supply. So you can see that I cannot make 215 195. Okay, so I cannot reduce the values, but I can make 195 equal to 215. How can I make? By adding a dummy variable called 20. So that is what we do here. Because as you see that the total sum of supply is less than the total sum of demand, so what we will do, we'll add additional row. So we'll add additional row, we add additional dummy row, we add additional dummy row, we add additional dummy row having having cost element. We will put cost element equal to 0, having cost element 0, and the total sum of supply, and the sum of supply to be 20. Okay, for that row, sum of supply to be 20 for that row. So because we want to make 200 195 to 115, and add total sum of supply equal to 20. Okay, and add total sum supply to 20, that is the dummy row total sum. Okay, that is the dummy row total sum, that is the dummy row total sum to 20, so that the total demand is equal to total sum of demand is equal to total sum of supply. Clear, right, everyone? That we have to do here. So we'll do that. So I hope you understood this. So let me just add a dummy row here. Let me add a dummy row here. Okay, so let me add a dummy row here. So after adding a dummy row, after adding a dummy row, okay, so what would be your problem? How your problem will look like? The problem will look like origin. You have to increase one. It is O1, O2, O1, then O2, then O3, and then O4. You have to add a dummy row, and the sum is demand. Then the sum is demand. Here this is demand. This destination is given. Then the value of that is 6, 11, 10, and then this would be 0. You're adding a dummy row. This is D2. D2 is 1, 5, 12, 0. Then D3. D3 is 9, 2, 0. And then D4 was 3, 8, 7, 0. Then you have to add a dummy row. And the total sum of supply is equal to 70 plus 55, then 70 plus 55 plus 70, and this you added a value 20. Okay, so let me just put with some other color. Okay, let me just put another color, that is 70, this is 55, this is 70, this is 20, and then your total demand was how much? The total demand should be 215, right? Yeah, total demand should be 215. This should be 85, 35, 50, then 45. So this is 5, 10, 15, 1 carry, 11, 12, 12 plus 9, 21. Should be like this. Should be like this. So yeah. So what I can do, I can find the initial basic feasible solution. Now here the total demand is equal to total supply. So I can find the initial basic feasible solution. I can find the initial basic feasible solution. And how can I find penalty ones? So penalty one, then penalty two, penalty three, like that. So penalty I can find. So 3 minus 1, this is 2. Then 5 minus 2, this is 3. And 7 minus 4, this is 3. And this is 0. This is penalty 1. And like that, I can find the penalty column wise. Like that, I can find the penalty column wise. P1. So this is 6. This is 1. This is 2. This is 3. Okay, so the highest penalty is 6. That will enter into the solution. That will get entered into the solution. So the least value here is 20. So I can put 20 on this. This will become 65. This will become 65. Okay. So now I'll find the second penalty. Second penalty this. Then this is 4. Then this is 2. And then this is 4. Then and then this is 2, and then this is 3. This is 3. So out of that, the largest one is 4. So I can go with any column. Suppose if I go with second column, the smallest value is 1. So I'll put 35 here. So I'll put 35 here. If I put 35 here, if I put 35 here, 35 is done. It cannot be done for any other here. This will become 35. Any doubt, anyone? So this is 3. This is 3. This is 6. This is 3. This is 3. Then third one. This is, if you find this, the third penalty. And this is 4. Then this is done. Then this is 2. And then this is 4. So see guys, out of all penalty here, the largest one is 6. So the smallest element in this row is 2. So this is 50. This is 50. This is done. Nothing can be put on this. This will become 5. So if I find penalty 4, so this will be 3. This will be 3, and then this would be 3, 3, 3, 3, and then penalty 4, penalty 4. So this is 4, 10 minus 6, 4, and then hmm, then 4. Yeah, then 4. So you can take any 4. Suppose if I take first row, 4. Hmm. So there you can, smallest element is 10 there. So here the demand left is 65 and this is 70. So 65 I can put on this. 65, this is 10, the left one is 5. So the P5, if I find the P5, P5 here is penalty 5, this one is 6, second, third done. This is 6, second, third done. And then fourth one is 4. If I see the penalty here, P5, the penalty here, if I see the penalty here is 3, penalty here is 3, and then this is 8, and then this is 7. The largest one is 7. The largest one is 8, sorry. So if it is 8, so this how much you can put 5 here, right? You can put 5 here. So this will become 40. And then you can put 5 here. So it becomes 35. You can put 35 here. So your allocation will be done. Clear, everyone? Then we'll check the degeneracy and other things. Okay, so let me just write down the data again. So after, so we solve it by initial, we determined initial basic, we determined initial basic. We use Google approximation method, and we determined our initial basic feasible solution. We determined our we determined our initial determined our so we determined our initial determined our initial basic feasible solution. Determined our initial basic feasible solution. We determined our initial basic feasible solution by Google approximation method. So the solution, what we get for this, the solution, what we got for this was 6, 11, and then 10. Then this is 1, 5, 22. So then 9, 2, 4. Then this is 3, 8, 7. Okay, then yeah. So the allocation what you did was 35 on 1. So 35 on 1, 35 on 1. And then again on 3, 35. Again on 3, 35. And then on 2, 250 on 250, then on 85, on 85, then 1065, then 1065, and then 75, and then 75. Then we had 000, right? 000. We made dummy row. 000. On zeros, if I talk about zero, on first 0, 20. On first 0, 20. So the first 0 allocation was 20. If you see the test of non-degeneracy, you have 4 column and 4 row. So 4 plus 4, 8 minus 1, 7. Total allocation to the 7, 1, 2, 3, 4, 5, 6, 7. Total allocation is 7, fine. So what we will do now, we'll check the test of optimality. Now we'll check the test of optimality. The test of optimality. 1, 2, 3, 4. Let v4 equal to 0. I believe everyone knows, no, by this time, you know that for occupied cell, we follow the formula Cij is equal to ui plus vj. For unoccupied cell, we follow the formula Cij minus ui plus vj. I think everyone should know this formula. So this cost will be 3, this will be 8, this will be 7. And then this is 10 minus 7, this will be 3. So this will be cost is 0. So 0 minus 3, this will be minus 3. Okay. Then this is 1 minus 3, this will be minus 2. So we are done for occupied cell. Now I'll do the allocation for non-occupied cell. So if I talk about the allocation for non-occupied cell, so first if I talk about this cell, so this cell, if I talk about allocation, the u1 plus v1 is 6, 6 minus 6, 0, positive. Okay. Then this cell, if I talk allocation of this cell, so this cell, okay, still have not put the value, v3 value. This is cost is 2, and this is 2 is equal to 8 plus v3. So this is equal to minus 6. So now if you see this v3, that is minus 6, and that is plus 3. Minus 6 plus 3 is minus 3. So 9 minus minus 3, that will be plus 1. Okay. Then 11, if I talk about this cell, so this cell, the cost, this is 3 plus 8, 11. So 11 minus 0, so positive only. Then this 8 minus 2, 6. This would be 6 means minus 1. This would be minus 1. Yeah. So it means our solution is not optimal. This is 5. This would be positive. This would be 1 positive. So this would be minus 5, 0, 0, minus 1, 5 positive, minus 9 positive, positive. Everything is positive, only this is negative. I'll make it optimal. So how will I make it optimal? Non, you can see now which are unoccupied cell. These are unoccupied cell where I cannot make loop. These are unoccupied cell. Making loop, I can only make loop on occupied cell. So I can make a loop here like this. So this is A, this is B, this is C, this is D. If I make a loop like this, let A is equal to theta, and B is equal to, this is, put sign now. Put sign on this variable. This is plus sign, minus sign, plus sign, minus sign. So B is equal to 5 minus theta. B is equal to 5 minus theta is equal to 35 plus theta, and D is equal to 35 minus theta. So out of all negative values of theta, the theta would be equal to 5. So theta is equal to 5 equal to A. B is equal to 0, C is equal to 40, equal to 30. Clear everyone. So let me do this allocation. Let me do this, then we'll check the test of optimality. We'll do that. So this would be, this is 6, 1, 9, then 11, 5, then 2, 8, then 10, then 12, then 4, then 7. Okay, then I added dummy row 0, 0, 0, 0. Okay, so the allocation, if I see the allocation, if I see the allocation, this are not, so 35 become 35 become 40. So we have 35, 235. So D minus 1. D is 30, C is 40, D is 30, D is 30. This is 30 and then 40. This is 30, this is 30, this is 40. And then this 5 become how much? 5 become how much? 5. This 5 is 5, allocation is 5. 5 is 5, allocation is 5. And then 2 plus 50. The allocation on 2 was 50. Allocation on 2 was 50. 8 allocation came on 5. And then 1065, then this is 1065, then 0, 20, 0, 20, 0, 20, and 7, 5. So this U1, U2, U3, U4, then V1, V2, V3, V4. So let, if U1 is 0, then this would be 1, this would be 3. Then this would be 4, this would be 6, this would be minus 6, and then this would be 4. I hope this is clear with everyone. The solution earlier was optimal 1, 2, 3, 4, 5, 6, 7. So we'll check the test of non-degeneracy, that is done total number allocation is equal to m plus n minus 1. Then non-occupied cell, this is 6, 0. Then this is U3 value of not put. U3 value, this is minus 2. So then this is U1 plus U3, that is minus 2. 9 minus minus 2, positive, positive, positive. Then this is 7, positive. Then this is 10, positive. Then this is 5, positive. This is 2, 2, that is positive. 4 minus 2, 2, 4 minus of 2. Then this is minus 5, 0, 0 minus 5 positive, minus 8 positive, minus 3 positive. I think now everything is positive. You can check the solution. Everything is positive. So I can find the cost, guys. I can find the cost, total cost. Here this would be total cost of this would be 1 into 30 plus 3 into 40 plus 5 into 5 plus 2 into plus 10 into 65 plus 7 into 5 plus 0 into 20, that will be 0. 30 plus 120 plus 25 plus 100 plus 65 plus 60 50 plus 7 plus 650 plus 650 plus 35. This is 60, 60, 90, 90, 190, 190 plus 120, 190 plus 120 plus 650. 6, 7, 8, 9. 960 will be the cost. Cost what you will get is 960. Clear? Guys, everyone understood this? Anyone, any doubt? Everyone clear with this? Any doubt, anyone? So I'll do this much today class. We'll continue discussion on unbalanced transportation problem tomorrow. We'll try to see the problem of unbalanced transportation problem which came in your exam in the previous time. So I hope you people can understand this, guys. Okay, solving is very important. You can easily solve the problem. And if you get unbalanced transportation problem, you need to make sure that your total number of rows should become equal to the total number of columns. Okay, that part you take care, and the element inside the matrix should be a cost matrix. So if you take that much care, your work will be done. Okay, guys. So I'll end the class. I hope whatever I've done you have understood. So with that note, I'll end the class. Thank you, everyone.